So this is building on research of my research, my NSERC Discovery Grant, which is focused on, initially focused on preventing what I call the data double spend. So where people, where people would consent to the use of their data, and then their data would be taken and used in a way that they didn't consent to. So kind of this fair data economy idea. And then related to that, I'm also involved in another research group called Inter Pares AI, and I started to look at privacy in AI. How can we use AI to detect sensitive information in data sets, but then kind of realize that we can get so far with that, but maybe decided, well, let's flip the problem on its head and say, let's assume all data is private and sensitive. How can we deploy a new category of technologies called privacy enhancing technologies? So I started to collaborate with a group of researchers. Dr. Zihua Huang is one of our adjunct professors. He teaches our blockchain software engineering course, for example, Foundations in Blockchain, and he was working on federated machine learning and privacy. So we kind of found common cause. We're developing Orchestra, which the problem we're trying to solve is that, like as Chen was explaining, we've got lots of potential with AI agents, all good things will happen. But we face a lot of barriers to those good things happening. So things like bias and discrimination in AI, copyright, data monopolies, privacy violations, which is what I was particularly interested in and inspired this research, lack of transparency, and so on. And these issues are likely to prevent AI. So as we were talking about before, we want our AI agents, but we don't want necessarily everybody knowing what, how we think. That'll totally, our brains will get hacked if, our models, our individualized AI models can be leaking data all the time. So we came up with the idea to create Orchestra to solve that problem. This is a problem we're trying to solve for. And so we have developed a prototype that really tackles a number of these issues towards a fair data economy. So transparency and trustworthiness is provided by blockchain. We're using a privacy preserving blockchain called Oasis. For now, in future it could be a different blockchain, but this is the one we're building on now. It also has privacy-preserving smart contracts. Data ownership and sovereignty is achieved by a compute-to-data model. This is kind of a paradigm that is typical of privacy-enhancing technologies, and it's often coupled with the use of TEEs or trusted execution environments, which Chen previously mentioned. So the idea is that your algorithms visit the data and your data doesn't get centralized and visit the algorithms, and this is a federated machine learning model. So as Ivan was explaining, you have your various owners or custodians of the data, and the algorithms go out and they train or they compute over the data, and then the models are developed that way. So it's an open and interoperable ecosystem. It's the particular platform that we're using. We're using Oasis blockchain, but also a platform called PontusX, which builds over Ocean Protocol, Oasis, and it's compliant with the European Union's Gaia X identity framework. And other sector-specific open and interoperable frameworks. Through smart contracts and the use of blockchain, we're able to provide for decentralized governance and payments. We're using an experimental digital EU right now, but Oasis uses the Rose token, but our particular implementation is using an experimental digital EU that's provided by a Finnish company. That's what they're working on. Obviously, with smart contracts and blockchain, we have traceability, so we can track intellectual property and copyright and attribution. We can provide ethical data processing and AI through decentralized governance and community ownership. privacy preserving using the compute to data, TEEs, and the Oasis blockchain. We will use other technologies, but we haven't built those in. And so like future work is kind of like a continuation. And we do have plans to make it sustainable and responsible through carbon offset accounting as well that will integrate into the platform. So this Pontus X, there's quite a few companies that are building on Pontus X. So like Airbus would be one of the bigger ones, but a number of, so we think it's like a robust kind of a framework that has some legs to it. And you want, when you're building on an ecosystem, to pick the right horse. And we think that this is probably going to be a good one. So basically with Pontus X, we will deploy our own portal, but Pontus X right now doesn't provide for federated machine learning, and it doesn't provide decentralized federated machine learning in particular. And so what do I mean by that? I mean, okay, if we're talking about federated machine learning, it doesn't provide where, you know, you can compute over a number of different data spaces or data sets. It's only, you know, one data set, one computing job. So we've now developed the capability that we can provide for decentralized, for federated machine learning. But in federated machine learning, when you are training the model or doing your compute job, from the computing at the edge, you have to pass it back to a model. You have to aggregate the results, right, and have a centralized model. So that's centralized, and we don't want that. What we want to create is a fully decentralized aggregation layer, and that's going to be Orchestra. So this is really what Orchestra is all about. It's a fully decentralized, new novel protocol for federated machine learning in a fully decentralized way. And so the idea is that we would be using this platform, but we are going to be implementing a protocol, our Orchestra protocol, so that if you want to compute directly just on one data source, you can do that. But if you want to do federated machine learning over multiple data sources and in a fully decentralized way, you can do that too. And so we'll be having, you know, pathways through Pontus X that direct you out to Orchestra if you want to do fully federated machine learning. So right now, I've got a little video I could show later if anybody's interested. I'm not going to play these videos because these are actually outdated. We're rapidly developing, and the latest video shows some more of the capabilities that we have. But the idea is that the regular federated machine learning, you know, that we could deploy using Pontus X is a kind of a Web 2 model. We want to go to a fully Web 3 business model. And we want to start deploying. We've already started with cultural computing, humanities computing. I'm an archival scientist by training, and so we're working with archives to upload archival data sets. Why? Because archival data sets, first of all, they are public, many of them. They do have sensitive data as well, which we want to protect, and that motivated this question. But a lot of the archival data is quite heterogeneous, whether we're talking about textual data, we're talking about numerical data sets, or we're talking about imagery. It's quite heterogeneous, and if you can figure it out with cultural computing and heritage data, you can probably deploy that across a number of different scenarios. So we have already started working with emails. So we're working with the Enron open email set, but we're in conversation with actual archives. For example, the National Archives of Cameroon, the National Archives of Ghana, and other archives where we would actually start working with their real data. And then related to that is health. And so health presents very similar archives. Oftentimes you'll get imagery and you'll get test results. Those are as Ivan was saying, images can be quite difficult. Test results, you can present like biomarker data in numerical format. That's easier in terms of like a more standardized approach, but it's the clinical records that are quite heterogeneous and difficult. So they're analogous in many ways to the archival data. So we think health would be good. Maybe, supermarket data could be another, avenue. And so if we just compare, so orchestra, like in the cultural space, Ancestry is kind of a key centralized company that they sold in 2020 for $4.2 billion to a private equity company. OneTrust it's roughly valued at about $4 billion right now. And these are centralized Web 2 based companies that are working with a very similar data. So Ancestry started working with National Archives. They built a nice little interface for tracing your family history. And, they started in the, late 1990s, I guess it was. So, over the span of a number of years, but still 4.2 billion. OneTrust is much newer. It's moving very quickly in the health space, but it is only like the features of both of these have nothing on what we're proposing to do, and certainly can't provide for a fair data economy. And Ancestry's moved into healthcare with their DNA. You can do DNA testing to test your ancestry. So there's an increasing overlap between these cultural heritage and health spaces. So anyway, how we're planning to capture value with this, and this is an ongoing research project. It's not like in my mind, I don't really separate research from actual. I like not to separate it from actual real world deployment. I like to do my research and do stuff. And so we're still exploring how can we apply privacy enhancing technologies to archival data, which is the inspiring research question to this. But, obviously things like compression of data over networks. If you're deploying training AI models, and you've got an aggregation layer, and you've got many rounds that you've got to transmit, that's a big problem to be solved, right? So this is why I'm kind of presenting this, because I want, I think we've got talent here and we can do this. This is not going to happen with just one researcher, right? So, but how can we capture value? So transaction fees, uploading data, right now, if we just did sort of break even, right now it's costing us 0.22 digital euro to upload data sets, to do the basic uploading and algorithm and so on. We think that there could be an uplift that we could charge over top of that, which would, with a number of transactions, make us, revenue positive in as little as 4 or 5 years. There's also providing for compute to data infrastructure. So with a compute to data model, some will want to host their own TEE, but others will just be happy to trust another, host, and so there'll be some way that we can do that. Transaction validation on the decentralized protocol itself, so typical Web3 approach. So we're really sort of proposing a Web 2, Web 3 combo business model. And, there's custom algorithm development, data integration and pre-processing. We were talking about those issues, which can be provided all as services in the broader ecosystem. So this is our research team right now. We're mostly based in Canada and Spain. We're starting to grow maybe into to the Czech Republic as well. We're talking to researchers. I don't want to, this is kind of a business pitch, but more than the research side of things. But yeah, we are looking for contributors, research contributors, advisors, and early stage investors in what we built. So yeah, that's kind of, how we got started. and what we have built. I've got a little demo of bits and pieces of it. Yeah.
I have a quick question regarding to those data. Do you think the concept of tokenization of assets can be incorporated in your practices?
Yeah, that's what we do. So basically when, let's say an archives has data that it wants to share. So what it does is it basically creates some metadata. It uploads a decentralized identifier, which the research party or the algorithm, they can't see where the data is actually located. It's just, it's a hash, and it's used for the service to locate where the data is, to find the compute environment, but nobody sort of sees that. But basically through the application of a decentralized identifier, the data is actually tokenized. It's turned into,
It could be
NFT,
exactly.
basically. But it's not an NFT that is transferable. It's an NFT that it allows for access. It functions as an access token in this case. You can download. There's a facility to download data as well. So some sensitive data we were talking about before. You have different types of data. Maybe you're okay with people downloading your data as well. So that's something that can be accommodated on PontisX, and we would incorporate that as well in our first ecosystem deployment, which is called ClioX, which is the cultural heritage oriented one. And so you could tokenize that as well, but we think that for longer term, that compute to data model is really going to be the more popular model, because it facilitates the Web3 business model. It facilitates for data contributors. You can get payment for providing high quality data. And why is that important? Is because we're already seeing that AI models are not finding high quality data to train on. They're going to start consuming each other, cannibalizing each other, and they're already being poisoned. So there's many examples of poisoning attacks already to reduce the efficacy of AI models.
That reminds me of this gentleman when you said you have different data sets from different supermarkets, right? So Save-On versus a Safeway, each one, maybe their data, you can create a package of tokenization of assets, NFT. One NFT represent all those Save-On data, one NFT represent the Safeways. So in order for them to have value, you can trade them, and trade them in a sense, and then you can trade with the other one, and then also trade with the AI, stuff like that.
Yeah. The kind of vision that we have is not so much trading of NFTs, is more that you tokenize the data so that you can provide access to it. You maintain control of your data, but collectively you are able to, let's say a supermarket has similar data, which they will on sales, and they would all benefit from having very robust models that have trained on all of that data. And they would all benefit from maybe, collective knowledge, but they don't want to reveal specifically, information from their own business. That's proprietary. So the idea of this compute to data model is that you can have several different repositories with similar data. The federated machine learning models, as Ivan was explaining, go out to those repositories. They train at the edge. They train in these decentralized compute environments. Those results are brought back to an aggregation layer in Orchestra. In a typical, in another deployment, you might just have like a centralized server, but we're trying to build something that's much more robust and decentralized and Web3 oriented, so that from a business model standpoint, those who are running nodes to make the training more robust and secure, and we have we're working on refining our protocol, our consensus mechanism for that. We're working on our white paper now and refining that deployment. We can basically, we'll do a token issue. You will be rewarded tokens to maintain, to do the training, and you can pay in tokens for the training. So it operates very much like you see in a lot of the protocols. So it's providing a security guarantee as well as providing the incentive structure and the economics around the services being provided.
Yeah, the reason why I mentioned tokenization because I'm in the fields of finance, so I really want to incorporate finance with technology because there's the BlackRock, Larry Fink, he's right now the big proponent for tokenization of assets. So he's going to tokenize securities, tokenize real estate, tokenize government bonds, treasuries. So in that sense, the data is also an asset.
That's right.
It can be tokenized. It has value to it.
Yep.
It's not only can be trained AI, you can trade and create value based on those data.
Absolutely. So if you want to tokenize and sell your data, you can do that already on platforms like Ocean Protocol. We can basically do that. I think we could accommodate that if we wanted to on this platform. We're not really trying to solve for that, but we can already accommodate it with the capabilities of Pontus X. What we're trying to solve for is, like a fully decentralized Web3 federated machine learning environment that is highly privacy preserving and secure, because we think if we want to have AI agents that we can truly trust, that realize some of the economic benefits without the risks that we know we face, like that Chen mentioned, we need a solution like this.
Yeah, this is probably one of the use cases you can apply to the Vancouver local real estate markets, right? You train those AI by feeding into the local real estate listing informations and then create tokens for each real estate or commercial properties. That would be awesome. And then
in different developers, different. The idea is that you incentivize, you provide a way for groups that would normally not share very sensitive data to be able to share that sensitive data, to collectively benefit from that sharing by having more robust models and having compute outputs, using those AI models that are much more accurate and comprehensive, basically.
And much more efficient. Compared with the human interaction.
So like if I had my AI model, it's not just like my own intelligence, but collectively, if we're all building models that build on your intelligence and all of our intelligence, then all of our models get a lot smarter.
The real estate broker can be out of job.
So you're not going to build the models themselves, though. You'll just be a gatekeeper for the data.
We're not primarily focused on that, but we're finding that we are building the models because because we want to do privacy preserving. We have to do some pre-processing of the data when we tokenize not tokenize the data in the blockchain sense, but tokenize the data in the data science sense. So we're building custom models that do some, basic formatting, some masking of the data, some basic cleaning of the data, and then get it ready to pass to. We have a interactive visualization web interface, so you can get the output and you can get the raw output, but then you can refine it. You can interact with it and customize it. If you're looking at text, we're mostly looking at text right now. Like I said, we're playing around with the Enron, which is an open source email data set. If I want to have stop words and I want to change the visualizations, the way it's presented, I can do that through the custom web interface as well. So we're building out those kind of data sciencey capabilities as well into our algorithms, but we'll be able to deploy, algorithms that are contributed. Right now, we want to focus on algorithms we trust because that is that do what it needs to do functionally, but also that we trust. We know the source of the algorithm. It's not going to leak data. It's not going to, somehow, do something it shouldn't do. So that's also part of the governance structure that we're putting in place for this fair data economy, which we think is the right way to go for.
When are you going to get to health?
So I'm hoping to get to health pretty quickly, because I have also done some work in the healthcare sector with a spin-off company, a UBC company actually called Molecular U. They do AI-based health intelligence, and a couple years ago I developed for them a dynamic consent system. We think that technology can be integrated into this. And they have developed, quite a few clinics that they're working with, so that might be a fast track into health with us. But we'll have to see how that evolves. Like, it's very, very early days. Mostly I'm focused on the archival data because it's public, it's open, and it's very similar to some of the clinical data. And so it won't be this year. It'll probably be next year. This year we're focused on archives, and so if I look at like year one, I don't know where it is. Year one, we're focusing on archival institutions, and it's more like in year two that we'll start to focus on the.
Where do you think you're going to get the health data from?
So we hope that we will be able to partner with companies like Molecular U, who already have health data from their client base and connections to clinics. I think it will be from clinics and private hospitals myself, and so we'll focus on that. But that's the strategy now. We will have to see how that plays out as we evolve.
Just as a segue, and I hope I'm not taking time, but another alternative, and I don't even know how it would fit, is like I said, the supermarket industry.
Mm-hmm.
Where, as a classic example, if it's going to snow in Montreal this weekend, you should reduce the price of your pineapples. Because if it snows on Friday, no one's going to come in the store on Saturday and Sunday, and your pineapples will go.
Right.
And then there's myriad other things.
Yeah.
But as I said, I deal with a number of supermarkets, and each one of them give me subsets of data anonymized in certain ways. So I'm not supposed to know that it's pineapples, but of course it's easy enough to figure out it's pineapples, whatever. I don't even care if it's pineapples or apples. So it's
Right.
up to you. And other products, because consumables will go up and that sort of thing.
Yeah.
But I get these subsets from different supermarket chains,
Mm-hmm.
who are actually just giving me, in some cases, those are subsets from every store, from 1,500 stores across Canada. But it's not supposed to be used in a model that the other companies can access or learn from.
Right.
But I am taking, Safeway's data and Superstore's data, and separately building a model around each one,
Mm-hmm.
and then giving them back a better model.
Yeah.
But to the extent that, I'm going to say the C-suite level knows, oh no, I'm not letting anyone else see your data, which is technically true.
Yeah.
The data guys know that all these things are being interchanged and learned from by their models. But anyway, so
we've seen the same thing in agriculture as well, and in fact, the Spanish team is working. They started collaborating with us because they're applying this technology to the agricultural sector. So there's no reason why we couldn't work with supermarket data. It's just
Yeah, but and I'm just saying it might be an easier access for you than healthcare data.
It could be, yeah.
I'm
Especially
not sure.
if we had partners that we could work with. Yeah.
And that's sort of what I'm throwing out.
Mm-hmm. Yeah. Well, let's talk. I mean, we're definitely with a Web3 model with federated machine learning and centralized aggregation. We're ready to go. The fully Web3 model, we're still refining the protocol. I don't know how interested you are in participating in a fully web, like being like a validator running nodes. You don't have to do that. It could just be like you use it as a service. That's totally fine. Many archives will do that too. But there is an opportunity to, run nodes, participate in the network, do validation, own token, stake that token, and earn money on, in a kind of a Web3 fashion as well.
On slide 12, you had a revenue curve that had a big inflection point. I'm not sure I really fully understood where that inflection comes from. Is there a minimum value in terms of size of data before you get there? Because that was all in transaction fees.
Yeah, it's all transaction fees, and so it's kind of, saying, well, there'll be exponential growth, and as you get more data, you'll get more, researchers or uses of that data. So it's kind of like a 10x, exponential growth curve. I don't know how accurate a visualization it is. It's like most startups, it's like, oh, look at us, we're we're going to take off. But we did, we did look at if we had 10x growth in the number of users and the number of transactions, data uploads, and the number of algorithms and the number of transactions using those algorithms. So there was some thought put into the representation there. Yeah. So basically, it's about 5 million transactions of various sorts that each generating about like the equivalent of a digital euro. Euro after 4 or 5 years would make us revenue neutral or positive, right? We wouldn't be burning if it all works according to plan. But but we tried to go conservative because we think there are other ways of generating revenue as well by through once we move to the Web3 model by the token issue, validation payments for running the network, for providing compute to data infrastructure, and so on. So there's a number of different ways that we have ideas about how we can capture value. It's very early stage. We'll have to see how we pivot to do that. Yeah. But this is all still like, there's like really good research problems in here too. So that's why I think we could, like Ivan, I don't know if you have, any interest in like the whole, the challenges of when we go fully decentralized and deploy the consensus mechanism and the validation for many layers of neural nets is going to be a big bandwidth challenge for us, and we're not quite sure. We're focused more on the theoretical aspects of the consensus mechanism than the actual technical challenges of deployment. There's many security challenges, like we've got to harden this whole thing if we want it to be privacy preserving. So, how do we do that? We've got to pass trained data to the aggregation layer. Do we do that through zero knowledge proofs? How do we know that the nodes aren't cheating? So correct behavior. We think we can do that through our consensus mechanism, but there may be other things that we need to think about. So the economics, the financial aspects of it, like how do we, how does the decentralized Web3 model work from a financial perspective and a business model perspective? Lots of really challenging research questions from lots of different disciplines. My discipline is archival science, so it's like working with the data. How do we analyze that, data in very heterogeneous forms and bring it together to make it computable, basically through this mechanism. And so there's some good. For those who like a challenge.
I can't help to bring down the storage cost.
Yeah, exactly.
That's my expertise.
Right, yeah. And also like how it all, like the actual proving out the engineering side of it from a a lot of it is very, it's applied and it's implementation, but a lot of the things that we might want to do, like the consensus mechanism, we'll have to, prove that out theoretically before we deploy,
Yeah, that's a lot of work. But on the positive side, based on my observation of some like major one blockchains, their core protocol team smart, just like 5 to 7 smart developers. So in other words, we don't need a big team to really deploy.
No, especially if you use like an open source, if you're creating an open source community, then we can, the idea is that we contribute. We don't need like a big centralized development team.
That's good, right?
Yeah.
But on the negative side, if like security, maybe in early years it's okay, but if security is a major concern, right? You need to spend millions of dollars on the so-called auditing, right? This and that. Luckily, David Wang knows this business very well.
Exactly.
Yeah, he will figure out smart ways.
That's, exactly. He knows auditing of smart contracts and security. And we also have a collaborator through Inter Pares who's really familiar with red teaming. So he's promised to do some red teaming.
Okay. So it's about my ongoing research program, right? Everyone knows AI 1.0 is just a traditional machine learning. Then we had this breakthroughs, deep learning, right? Advanced models like large language models, AI 2.0. What is AI 3.0? It's kind of beginning, what is happening, because for two things. The number one, right, some advanced models, they already deliver the so-called superhuman performance. For example, right, on Mars, Olympia, or on some programming tasks already, right, kind of outperform humans. That is one trend. The second trend is agents, right? They can act as our personalized assistants. So by combining these two, I think it's almost clear that in the future, right, we will have more and more agents doing something on behalf of us, and they will, right, kind of deliver this superhuman performance on more and more tasks. This is like a background. Let's write about the vision. In the ideal world, every AI agent will work, the keyword is harmony, right? In harmony with this human partner, and AI agents can collaborate with each other, right? So here is a concrete example, because I'm a lazy professor, so sometimes I really wish, right, my AI agent can anticipate my needs even before I tell them what I want to do, right? They figured out, you are going to attend this meeting, have you booked the flight? If not, here is the choice, something like this, right? And the second, AI agent will elevate my capabilities, right? So this is one concrete example. The second is my agent will work with Vicky's agent, right, to organize BTS, 2032, something like this. So what does this mean? It means that it's not only about automation, right? Automation is just one side of the story. It's more about the so-called collaborative intelligence. In order to fulfill this vision, we have many things to do. For example, right, this company SSI, safe, super intelligence, right, just raised $1 billion because their idea is very simple. AI agent is like a black box. We want to make the black box safe by using whatever technology, right? I think they just have one website, $1 billion, because this problem is so important. That is not my expertise, so that's why, right, I'm asking a different question. Now imagine, we have more or less these safe black boxes, right? These black boxes will interact with humans, and they will interact with each other. So what I want is an infrastructure that is both secure and scalable for billions of AI agents, right? The challenge is billions of AI agents. It's not for this year, maybe it's for 5 years later. If we have billions of AI agents, how can we have an infrastructure that is both secure and scalable? And a traditional solution maybe doesn't work well, right? Because imagine if these super AI agents are controlled by 3 companies, not good in terms of freedom and innovation. And for Web3 people, I think I don't need to convince you about the keyword permissionless or decentralized, right? But for those who are new to Web3, I highly recommend this article from an MIT professor, right? Why decentralization, permissionless is important. As an analogy, it's like internet, right? Internet is open and permissionless infrastructure. In the history of internet, some governments, some companies, some organizations tried hard to control internet. Oops. So maybe just a collection. Yeah. So, but still, right, internet survived as an open and permissionless infrastructure. Okay, now we have a well-defined engineering problem, right, which is to build an infrastructure both secure and scalable, and it must be permissionless. Right? In order to do this, it's not one project, right, and it can be divided into many projects. Like the first one is about security, right, corresponding to the keyword secure. We hope that our consensus algorithm by design, right, is secure and is fully decentralized. I can talk for hours about this, but the short summary is current solutions are not good enough. Bitcoin, proof of work, Ethereum, Solana, proof of stake, they are not that decentralized. Still, right, some room to improve. And the second is about scalable, right? And this is hard. I can abstract a very simple engineering problem. By simple, I mean easy to describe. We can do the simple math. If you want to store 1 gigabyte of data on Ethereum, right, quickly, and I have a link there. So it costs you multiple million of dollars, US dollars, 1 gigabyte of data. What about Solana, right? Someone likes Solana, over $500,000 US dollars just for 1 gigabyte of data, right? That's why today, almost no on-chain agents, no the real Web3 way agents. What's the reason? So simple. The storage cost is so high. So what is the engineering problem? Bring down the on-chain storage cost to the level of AWS. Everyone maybe here, right, has a rough idea. Oh, sorry, I just thought you have a question.
No, I was looking at the information.
Oh,
I was
okay.
interested that
Okay.
current Ethereum and Solana doesn't work, right?
Yeah, I will share you a particular website. My agent did the calculation, and then I double checked. I verified the calculation was correct. I will share with you later, right? So now you see, right? This excites me. I'm an engineering professor. Now I have a problem to solve, right? I'm not afraid of hard problems. I'm afraid of no hard problem to solve. This will kill me, right? So this my only worry is no hard problem to solve. Okay, so almost solved this problem, and currently by working with an industry partner in Silicon Valley, we are able to bring down the cost to maybe 5 times of AWS. We want to push it further, maybe 10% higher than AWS. So, and then, because we are talking about agents, right? Roughly speaking, for Web3, every agent needs to have 3 things: identity, right? Money, which is wallet, and this on-chain storage, right? Every agent, ideal case, should have a dedicated on-chain storage. So that's why if Ethereum or Solana, right, would like to support AI agents in the future, I mean real support, not just some news articles, right? Build identities for agents, right? Build this wallets for agents. So this is right. First requirement, again, I just like define the problems. Right? The second problem to solve is that we cannot run like agent on our own machine. Right? Sometimes we need to run AI agents on untrusted hardware. So that's why right, TE can be used. But TEs have their own problems, right? That's why like we need to solve the issues of TEs. Like I'm very happy, like it's not my project. My former PhD student, right now is maybe research assistant professor in China, and in the past 2 or 3 years, his like focus was on this, right? How to make TEs better for these Web3 applications. And I'm proud of his work. So the third problem is I just chatted with Vicky right about an hour ago, and to make it like safer, right? Ideally, we should record the type of kind of interactions between agents and humans, right? Also between agents and agents. And we need to do it in a smart way, right? By recording certain interactions like permanently and in a privacy-preserving fashion. Right? This allows us to live in harmony with AI agents. If you want to know more about, this is not my idea, right? I just defined the third problem. So if you want to know more about this idea, very interesting recent paper. Maybe in the end, I will talk about this paper like a little bit. Yeah, so I will share the link maybe to True, right? So it's a very interesting thing. Okay, I think I'm done. The conclusion is just nonsense. It's just to have, it's written by ChatGPT. ChatGPT thought, after ChatGPT revised my material, like
You're not using DeepSeek?
next time, right? So this article is very interesting from like professors from U of T, right? University of Montreal, right? Like half of them, more than half, are Canadian researchers. Their argument is like this. Forget about AGI, forget about ASI. ASI is artificial super intelligence, even smarter than AGI, right? Even in the worst case, we just have the so-called incremental AI development, right? In the next 20 years, we cannot reach AGI. Even in this worst case, AI can give us some huge risks. Like, no time for me to explain, right? Read the paper. And what excites me is that some of my solutions have been mentioned by them. So maybe I'm on the right track, right? To sum up, if you can remember only one thing, a simpler engineering problem is to bring down the storage cost from $1 million to $10. That's engineering problem, right? If you want to really support AI agents, build identity, wallet, TE, and record interactions in a very smart way so that we can live in harmony in the future. So this concludes everything, right? So as you can imagine, this program keeps me very busy. Please.
I have a question.
Yeah.
I'm a faculty in computer science. I work on distributed systems, and blockchains are distributed systems, and so that's primarily kind of the reason I'm interested in them. And a lot of my work is actually with Chen on scaling blockchains, building more efficient, interesting BFT protocols that have kind of give you the same security guarantees, but are also very scalable for primarily permission blockchains, because permissionless is a completely different world. But since you started talking about AI, maybe I'll talk about AI. I have a bunch of projects on AI, but one line of work is around federated learning, which is kind of it's distributed machine learning, but without blockchain, and it's basically centralized. And even in that space, there's actually a lot of problems, and it's interesting to see kind of your proposal in ways in which you can address some challenges, but maybe some other challenges remain unaddressed. But in federated learning, in case how many have heard about federated learning? Anybody? just a few folks, the academics, have heard about federated learning. Not surprising because actually it's been very difficult to deploy these systems. So Google came up with it, and they were the first ones to deploy federated learning on Android devices. They actually, if you have an Android device, you ran federated learning. Maybe you didn't know that. But basically it's an example of this like cross-device deployment where you have like 1 billion devices and you want all of them to perform joint training of a single model. So that's one deployment kind of scenario for the federated learning. Another one is called cross-silo federated learning, where you basically have large organizations that participate. So like hospitals or universities or a set of companies. And you might have like, a dozen or maybe 100 of them, but you're not going to have 1 billion organizations. And in that context, the idea is like, to get medical data from one hospital to another, you have to sign like data transfer agreements, and you have to get data stewards to, agree to do this, and lawyers have to be involved. So it takes years to actually get data out of a hospital. So if you wanted to, still train a model on data across these different hospitals without moving the data, you would use something like federated learning. So the idea is that, devices all have data. We have a single server that kind of coordinates their activity, and each device locally performs a local kind of training step on their local data. And then they send the results, kind of the gradient, which is the change in the model parameters, to the server, and then the server aggregates them all together. And the aggregation is really trivial. It's just like averaging them. You just like sum this long array of integers, and you like average, each index. So really simple process at the server, and then once they have that global new model parameters, they push that all down to the devices. And the devices take the next step, and that's it. That's basically federated learning. But if the model gets very large, your network bandwidth becomes quite important. So you have to kind of think about, okay, I have 1 billion parameters. Is there some way to optimize for my network bandwidth? And so those are the kinds of problems that we've been working with in my group, is trying to optimize, like basically make federated learning more efficient. I've also tried to work on some deployment of federated learning, actually between hospitals, and that failed splendidly. And it was a really interesting failure because the difficulty was not actually building the system or even deploying it, because when you talk to researchers in hospitals, they're really excited about it because people work on rare diseases and things like this where they lack data and they really need to share data across countries and institutions. But the challenge is that it's really hard to do data science on that data when it's distributed. So before you train a model, there's actually a lot of steps that you need. So if you ever train a machine learning model, you need to clean the data, you need to kind of know what the data distribution is. You need to select the model. You need to, have a validation set that's representative of the data set. All of these steps require access to the data. Mm-hmm. And so if your data is geo-distributed and you can't see it, you actually can't do any of those steps. And so your final model is going to be garbage, right? Unless you have very good understanding of what those different data sets are. So as an example, there was one hospital in UHSO in Oregon, which had scans of like cancer scans, and they came from a machine that was different than the one in like Fred Hutch at Seattle. And so as a result, the scans had different coloration, like different backgrounds essentially. And so if you were to train a model for like recognizing a particular cancer cell type, you would fail gloriously because you need to essentially like normalize the backgrounds for all these images. And so if you normalize them, you can train really good models. And there's people here in biomedical engineering that have like state-of-the-art models essentially for this cancer type. But
can I ask a question?
Yeah, go for it.
Just by what you're saying, I don't know if by my limited understanding, you think that if the data is decentralized, it would be hurtful to train AI. It would be better to have a centralized data in order to train AI. Is that what it is?
That's an interesting conclusion. I'm kind of working towards that, but it's a strong statement. I think it's kind of nuanced, but it's really interesting to think about it because, based on
contradictory. You want some form of decentralization, but somehow it's ineffective to train AI in a decentralized way.
Well, the question is who wants it, So like I think one reason that FL hasn't been deployed by a lot of companies is that they don't actually want decentralization. They want to centralize all the data. They want to own it.
Yeah.
So, the previous deployments of FL that Google has made, they're taken down. They're no longer doing it because they want all your keywords and they want it in a server that they can study themselves and use for a lot of other purposes. GDPR notwithstanding. So,
If I could add, ironically, it relates similar to what work I do for the supermarkets, where they want the insights, but they don't want to give. Safeway does not want to give Superstore their data.
That's right.
And they don't want to. Neither of them want to give it to me if it's going to be shared.
Yeah.
So in many cases, what I'm doing is creating one model over here, matching it to essentially the thesis or the algorithm, whatever it is, doing the exact same thing over there, and then magically, on my end, sort of factoring the two together based on subsets of data or whatnot. So it's a very similar sort of problem where it's more political than anything, and both of them are happy to know that I'm taking someone else's information and making their model better, but I better not be doing it with their information.
That's right.
So it's really interesting.
It's a very fraught process, and I think you know a lot more about it than I do. I just have this one kind of experience with like the hospital context. So I think even for FL, this has been a big challenge. It's very robust as a technology. There's very strong guarantees in terms of the kind of machine learning guarantees and convergence. It's very efficient. There's a lot of open source frameworks that people have developed. There's a lot of researchers. It's been around for about 10 years and basically very robust. And yet still kind of hard to deploy, even though it does have this very simple architecture. It's just a star topology, with the server. And so the blockchain context kind of, that said, the blockchain context to me feels especially difficult, because if you decentralize it to a point where there's not even a centralized server to coordinate the gradients, you can make it privacy preserving, you can make sure the computation is correct and so forth, but I think you still are left with the same set of problems, that make federated learning really difficult to deploy. So that's like the challenge.
Yeah, and that reminds me of one of the terms that Peter Thiel said, is that by nature, the nature of blockchain is decentralized, but the nature of AI is centralized. So in that sense, in a way, just like the freedom and the law, so these two are contradictory to each other, but you have to find a certain balance. So in terms of individuality and privacy, each one of us would want our data be private, so that we prefer a decentralized way to keep our own data.
Yeah.
But on the AI side, on the efficiency side, it would be better for all the data being integrated and train the AI. So that will be an interesting thing to see in the future, how we balance these two.
Yeah, I think it also depends on if there was a data scientist in the room, they would say it really depends on the data. So if it's text data, OpenAI showed us that you could just grab data from the internet and just throw it at a model. And I doubt they do very much cleaning. They do a lot of data engineering, model engineering to make sure that it's not racist and homophobic and all these other things downstream, to make sure that that's model safety in some sense. But I don't think they filter it up front, very much, because it would be too hard, and it's why bother with that? You can kind of tune it later. So that's an example where you have this giant pipe and they can just suck in all this data, and they don't care, But still, there's a lot of model engineering, and in a FL context, it's too painful to do those iterations. There's a lot of back and forth, so it's much easier to do it in a cluster of GPUs. So, yeah, I think there's a lot of interesting ways to balance the two. For example, you could retain the data stays on your device, but maybe you have a surrogate of the data, or you have some. There's a lot of work on synthetic data generation right now based on data sets. And that's very popular right now, because I don't give you my data, but I give you a representation of my data. It's strongly anonymized, but it's synthesized. This is synthetic data, and performance of the model will go down, but it still gets you something.
Which is a zero knowledge proof, right? A ZK proof. It's I give you something enough, but I'm not really not really completely disclose my information.
You know, ZK is very strong guarantees. In this case, it's literally like data, like image data. You know, that approximates me. So maybe instead of a picture of me in front of this fountain down there, you know, my face is replaced with somebody else's face. You know, it's like, oh, well, you could use it for training people in front of fountains. You know, it's going to be good for that. But you don't need like my face in it, you know, to train a model. So that kind of use case.
The ironic thing is that I can probably back test through your clothes and your build and whatnot to find out who you are.
There's a lot of leakage, yeah.
And you know, on an individual level, if you're my ex-girlfriend, I can, which creates problems. But by and large, you know, no one cares because you have a billion people in front of a million fountains.
Yeah.
Can I ask? It might be a very rudimentary question, but what do you mean by federated?
Yeah, so the federation part of it is that people have to jointly cooperate, you know, and there's usually, you know, that centralized component is the thing that kind of coordinates it and brings everyone together. So there's sort of a...
So it's not centralized, it's each one contributes their own data but owns their own data.
That's right, contributes the training on their data, their output of the training on their data, right? But the data stays in place. The data doesn't move, right?
It stays with, if you will, the provinces or the individual countries.
That's right. The data stays on my device. I just sent you, you know, and that's there's been a lot of attacks on federated learning. It's actually really hard to make it private too, because when I send you a training, like an update to my parameters based on my data, those parameters leak information as well. And so there's a lot of attacks that make use of that actually to try to reconstruct the data.
So it is kind of a decentralized way of training data.
It is a distributed, yeah. Well, it's it's distributed, but it's centralized. You know, so it's that whole thing around, you know, decentralized meaning you have different administrative domains that may not trust each other.
Yeah.
In this case, you know, everybody trusts one another or has to in order for this to actually work. They definitely have to trust the coordinator, and people have been trying to relax that, and there's like different variants of federated learning, but essentially for it to be efficient and you know deployed, you kind of everybody has to cooperate.
So does the federated part of it or the centralized part of it redo their own testing?
They do not. I mean, if you don't trust some of the sources, so those are some of the attacks and defenses. So, like I could contribute garbage data, for example, which is the problem. And so the centralized coordinator could detect this kind of model poisoning, as we call it. And so there's, you know, you could have a validation set that you use to kind of check, you know, if this is like way out there, too weird. But in general, you know, if you trust everybody, then you don't need to do that. Yeah.
So this is the federated. It's just like the different type of blockchain. One is the private. One is the whole public chain.
Well, this is
There's
not,
a federated.
you know,
chain
this has
somewhere
nothing
in
to
the
do
middle.
with blockchains, right? So like federated learning is completely, you know, this is a concept independent of blockchains. And people have been trying to combine it with blockchains in different ways, you know, which I think is it's promising because it's already distributed, so it's kind of natural that you could bring blockchain into it, right? So starting with federated learning is a good starting point, actually. But like I said, I think there's some of those fundamental difficulties that won't go away.
So before I actually do my research update, I can quickly introduce myself. So my name's Ray, and I'm a third-year PhD student. I work for Professor Carty Potter-Burman, a professor from the EC department. And my research are mostly focused on the security of the blockchain application. So instead of the blockchain fundamental, the chain itself, or the consensus protocol, or the machine learning stuff that's going on the blockchain, I instead works more on the application layer side, which is different kinds of token, including the meme coin train that we are witnessing right now, and also the decentralized exchange. And also, it can go more complex into something like the recent derivative kind of product that's going on-chain, which is perpetual trading, that kind of stuff. So yeah, but how can the security plug into this kind of narrative, right? So I do a lot of on-chain analysis, and there's one thing that I figure out is that the documentation of the business logic or business plan of this blockchain application, they're actually pretty disconnected from the actual code, the smart contract they deployed onto the chain. So that this kind of disconnection will expose vulnerability of those decentralized blockchain application to the attackers.
You mean, what do you mean by disconnection? You mean the integrity of the data or the connectivity or the transfer of?
Well, I can give you a quick example. So, for example, if in the business plan, in the white paper, I said, well, for my protocol, for my application, I can support the exchanges of any pairs of tokens regardless of what kind of tokens they are. This is my business plan. But in the actual implementation, I only take care of the token which are standard. So for some order token, if it is not standard, for example, if it will charge you when you're transferring something for a fee, then this kind of like premise in your business plan is no longer valid. And so that this kind of like difference between the actual implementation of the code and the business plan, the stakeholder promise, is disconnected so that the attacker can jump in, trying to find any profitable point from this kind of disconnection, and then do the attack. So for me, the insight of my research, it's starting from the code itself, because on blockchain, all of your codes are open sources, all of the transaction, which means that the interaction to the blockchain application, they're transparent as well, so that I can build from top of the code and also the transaction, which means the interaction, and trying to summarize those interaction into their business plan. And then I can compare the difference between the business plan that I summarize by my tools with the original business plan, like brought up by the stakeholder, and then I would compare, well, if there's any difference, if there's a difference, will that difference create a vulnerability, which means a bug, in their business logic? If it is, it's an attack. So I'm doing this. And for the research update, I'm currently implementing a decoder from the contract interaction, which is the transaction, and rebuild it into a human understandable format, which is close to the business logic, as the stakeholder have written.
Oh, great.
Yep.
Yeah, that's awesome. That's
Interesting.
really
So does your work also include to apply those technology to the existing business instead of just startups? So I'm assuming the disconnect is probably due to the startups. They're not really business ready or they're not business proof. But for existing business, maybe their information, their data, their execution, their plan is more already been proved. So maybe this kind of disconnect will be erased, or you think you still have some disconnect?
Well, it actually regardless of the size of the business, because there are actually two groups of people in a blockchain application. The one group is the BD guys, the business guys, who take care of like designing the whole stuff on a higher level, which is like a business plan. And also there's another group of people, which is like developers. Did we receive some requests from the business guy? Well, you want this feature, which is like exchanging between tokens. Then I write the code. But there are always like this connection over their mindset. So that like regardless of like how large or how mature the group, the business is, there'll always be such disconnection. Unless there's only one guy who take care of planning the business, doing all the coding, take care of everything by himself, probably like the likelihood will become like smaller perhaps, but
Okay.
I provide no guarantee.
All right, thank you.
Do you have a question?
I can
I have
pass
a
it on.
question for you.
Okay.
So are you able to abstract away from develop some general principles for security principles that could provide a security framework for these businesses when they're developing their smart contracts? Is there something like an ISO 27001 standard for smart
Yeah,
contract
this
security?
this is a very good question, but like I have to admit that this is super hard, because like for the narrative over that blockchain application, it's usually case by case, because like their business are somehow somewhat different from each other, which will set them aside from the others' competitors, right? So I can only conclude a handful of like heuristics that like generally like universally work for those applications. So if I need to bring up one example, it is like for a lending platform where people can put in collaterals and borrow money out of the platform. So there are two major operations, which is the first one is borrowing, like put collateral inside and then get money out as the mortgage. The second key operation is liquidate, which means that there's another guy witness that, well, your collateral can no longer repay your debt. And then that guy put money to claim your collateral back, to repay your debt, and so that you're in a loss. So these two operations should be carried on by two different users. Because like the second operation, the liquidate operation will cause loss to the first user who like borrow money, right? But if these two operations happen in one single transaction, which means that this is carried on by the exact same person, maybe you're exploiting some loophole in that blockchain application. This is one of the heuristics that I think is the easiest to explain to everyone. Yeah.
The principles of separation of duties.
Yeah, the separations of duties, the conflict over interest, and if this kind of rules are violated, it poses some vulnerabilities. Yeah, and I still have a handful of them in my paper. I'm like targeting like the CCS, one of the top security conference, which is like due in, I remember like late April.
Great to see you guys. My name is Jarrett Vaughn. I teach solder in the Marketing and Behavioral Sciences division. And I've been teaching at solder for maybe about 10 years. And I've been in kind of the crypto space since 2017. And I'm not a researcher. I'm teaching faculty. And as Victoria said, I've worked with this organization on some of the blockchain courses. And then also launched an NFT course and a crypto course in addition to the two current blockchain courses a couple of years ago, and taught them through a couple times. And I've got a crypto podcast called the Web3 Prof podcast. I've done most of my interviews in person here in Vancouver, but I've now run out of experts to talk to who have a following, and so now I'm starting to do online interviews as well, which is pretty cool because I get a higher quality guest, as you would imagine, opening up kind of the whole world from the landscape of the whole world. I started UBC Blockchain Club with a group of students, I think in 2021. I went to my marketing students, and because I was talking about crypto all the time, and I said, hey, we need a club, and kind of resurrected, I guess, an old existing club, and then helping another group of students currently launch a UBC Bitcoin club. And so I'm primarily interested in working with non-technical students, in getting them into the space and connecting them in industry. I organize Solana Vancouver events. We have a co-working event every week downtown, which anybody is welcome to attend. And so I'm primarily interested in in Solana and Bitcoin is where I'm spending most of my.
Not Ethereum.
I don't really know anything about Ethereum. I mean, I interview people from Ethereum on my podcast, but I've never really been into Ethereum. And so I don't know a ton of what goes on.
You get Vitalik and
interview
him sometimes.
Can you introduce me to him?
Well, I have some sources.
Perfect.
Directly.
I would love to interview Vitalik or have him around. And
or CZ in a way.
CZ would be fabulous. And I'm really primarily interested in onboarding new people to the space. And so many of you are doing very technical research that is far beyond my understanding in this space, which I admire and respect enormously. But I would like to see courses here at UBC for people who are interested in getting into the space. And so I have proposed many times, and have proposed once again this week, to Solder to have a kind of like a blockchain, business fundamentals on blockchain type course. And I work closely with the mayor on Bitcoin policy as well, and he's now called the dean of Solder and asked them to have a course. And I'm hitting the business school at all different angles. I don't know if I'm going to get through, but my hope is that at some point.
We hope you do.
At some,
We tried earlier to hit them.
yeah.
We have to keep putting
Yeah.
pressure on. But
So hello everyone, my name is Yao Du, and I'm a PhD candidate from the Electrical and Computer Science Engineering Department. So basically my research is on the intersection of blockchain and AI. So I heard many of the professors today has already talking about how can we like decentralize machine learning or AI, how can we make profit from it. So basically my research can be divided into two parts. The first part is how can we decentralize machine learning training? And the next part is how can we decentralize the inference part? So basically, if we have an already trained model, then we need to inference it. So it's a totally different thing. So the first part, because I'm part of like the engineering perspective, so basically we focus on how can we decentralize the training to solve two issues. The first one is how can we solve the resources limitations? Because if we decentralize the machine learning training, then we ought to use like some low-cost devices. Then there are some limitations here. And the second issue in the training part is how can we, for example, in the federated learning, we have data pointing attacks. How can we evaluate all these kinds of data quality without knowing the raw data? So this is the second challenges that I solve. And in the inference phase, so which is what I'm currently doing, so we are more focused on like how can we reduce the cost. For example, if we all know the DeepSeek, right? Mm-hmm. So, but the DeepSeek, the inference will require like high GPU resources. For example, if you use a DeepSeek in the midnight of Canada, then you may not access it because in China or in other set of world, like billions of people, they access the one model. So that's a problem. And that's why we want to decentralize the machine learning inference. Because by decentralize this, then each one can have their personal agent, right? So then there's no need to use the high-cost DeepSeek. So we all have a personal deep.
Just like the blockchain network,
Yeah.
right? Everybody
Yeah. Yeah, so this is a high-cost issue that I have already solved. And also we have another problem which I'm currently doing is the test time adaptation, because when all the models are already trained and deployed, retraining it will become very expensive. So we cannot retrain it. But we need them to deal with some like data distribution shifts during the inference, because we want the model to predict the new data that they do not know during the inference phase. So that's the work I'm currently doing. So I'm currently in the final year of my PhD, and I have MATAX, the research project with Dr. Vicky. So we are doing the reliable and responsible AI. So that's part we are currently during the application phase. Yeah.
Yeah. Also, we need AI with love.
Yeah. Yes.
Yeah,
that's why we need them to be responsible and lovable.
Love human beings.
Yeah.
That's most important. Not exploit human beings.
Who is your supervisor?
Oh, my supervisor is Professor Victor Liang and Sarah Liang, and also I'm a student here supervised by David Wang, Zhehua Wang. Yeah. Thank you so much.
I'm the nominal supervisor of this.
No.
I'm Babak Tusarkani, assistant professor with the School of Engineering. My background is industrial and systems engineering. The focus of my research is operation supply chain optimization. So let's look at the current problem. What I'm doing, I'm using the knowledge that you are generating for the supply chain optimization. So now we have 25% tariff from US on the Canadian product. So what would be the consequence? The product or the Canadian product, it will be 25% more expensive for the Canadian, for the US consumer, right? So what we want to do, we want to have the retaliation from the Canadian government, right? 25% tariff on the US product. So again, what would be the consequence? The US product, it will be 25% more expensive than it used to be. So what we have said from before, so the problem is that we are going to we rely on one market, US market, right? So let's have shift our attention or approach to the multi-sourcing. So instead of the US market, we can rely on the European Union or the Latin America, right? So again, what would be the drawback of that strategy? So we will have multiple supplier, multiple manufacturer, then how we can control the confidentiality of the Canadian technology here. So when we know that about the supply chain network start from supplier, include the manufacturer or producer, include the retailer, ended up with the market. So we will have multiple supplier, multiple manufacturer. It's like the network. So it means that one producer or the manufacturer may have the relation with multiple suppliers. And those suppliers have the interaction with the other manufacturer in the other country. So they may misuse the knowledge or the technology that one specific manufacturer use that technology. So they may take the advantages of the technology. So from now on, this is our question. So how we can make the Canadian supply chain network more resilient. So for sure, we know that we cannot rely on the US market. So every administration comes, they have different type of strategy. So using digitalization, using the blockchain technology, how we can protect the whole supply chain network. That's the research that I'm working on it. So for sure, my research is on the optimization side. So we have supply chain network. The supply chain network include multiple modules. One module is the optimization. The other module, it can be the machine learning and the blockchain technology. That would be related to the master's research that she works on the interface of the blockchain technology and the supply chain optimization.
Yeah, very interesting.
Yeah.
Couple of more comments than questions for you. So one thing that's definitely come across my desk is that the European Union's digital product passport, which is using verifiable credential technology. Verifiable credential doesn't necessarily have to use blockchain, but it can use blockchain. And I think for some applications they are thinking of having like a European blockchain where the credentials are registered for the product passport. So I don't know if that is something that is on your radar.
Yeah, it's interesting. Interesting idea.
The other is, again, with verifiable credentials, what the BC government has been doing. I think you've been involved in maybe some of those discussions where they are using the verifiable credentials to differentiate the products as well. So, like, from a strategy standpoint, not only do we have to diversify in Canada, but we have a higher quality product. And we can differentiate ourselves in the market by saying, we've got a cleaner product, we have higher quality ingredients, it's produced, with under the right conditions, so like especially with critical minerals and so on, right? So the BC government has been experimenting with the use of verifiable credentials to basically signal to the market that mining outfits comply with, again, like the fair mining principles, and what that does is give them certain credits in the market, in a global marketplace, and then they can take those credits and they can get like carbon offsets and other things in the marketplace. So those are maybe a couple of developments that
Yeah.
are interesting for you
Yeah.
to know about.
Yeah, it's really interesting. Yeah.
My name is Mahsa. I'm a lecturer at UBCO. So my background is industrial engineering. Bobak already talked about the relation to the blockchain and the research that we are doing. Just want to provide you with a brief explanation what we are doing in our last research. We are working on information sharing in the global supply chain, considering the disruptions. The latest one, Bobak referred to the Canada-US tariff. We also addressed the disruption regarding the Panama Canal, a disruption that decreased the traffic in the Panama Canal, or the wildfire in BC. So we work on resiliency of the supply chain, which is closely related to the information sharing in the whole supply chain network. Different echelons in the supply chain network. We are trying to develop decision support systems. That one module will be the blockchain technology that focuses on the information sharing. The other modules are related to the simulation to see the performance of the whole global supply chain and validate the performance of the integrated modules in our decision support system. Yeah.
Wow, yeah, very timely, very topical. So you guys actually, are you getting attention from policymakers for this research? Are you working directly with them to answer specific questions, or?
So actually, it depends on the time. So I had the meeting. Because we are working on the wildfire as well. So the impact of wildfire and uncertainty on the supply chain network optimization. So if you may know that every summer in Kelowna we are struggling with the wildfire, and sometimes with the flood, because flood and wildfire is interconnected. So I had the presentation with BC Ministry of the Climate Change and presenting the research that was related to the supply chain optimization during the uncertainty. So it depends. So as I said, my research is the application. So and it depends on the time. So we are focusing on the tariff. What would be the impact of the tariff on the say Canadian supply chain network? What would be the impact of the uncertainty, like the wildfire and flood on the supply chain network? Sometimes we are working on the impact of those natural disasters on the food bank even.
Right,
So
right.
so we are doing multiple research and all is interconnected with the knowledge that you are generating. It's a complementary research.
Yeah.
So you know that Chen, I think you guys maybe came in after we talked about blockchain technology symposium that will take place in Vancouver, July 8th and 9th. So it's a pan-Canadian conference that Chen is actually the chair of this year, that is bringing together researchers, policymakers, and industry. And he's going to be issuing the call for proposals. We'll put it in the next newsletter. I encourage you guys to put forward your research on tariffs and the Panama Canal supply chain, because there will be policymakers there. They're provincial but also federal. So it's maybe a good opportunity to catch the attention of policymakers, and potentially for some research with the National Research, NRC, or I don't know.
That would be awesome.
Yeah, sure.
Sure.
Yeah, but
We will reach out.
it needs to get some good attention from the policymakers.
Yep.
Yeah.
Sure.
Great, good stuff. Well, I guess we're over time, of course, because we always are when we start talking about our research. And well, thanks you guys for coming. Thank you for your support and interest in blockchain at UBC, all of our students. So good to see you, visitors. Rob is the director of the Institute for Computing, Information, and Cognitive Systems, in which the blockchain at UBC's cluster sits. It's so great to see you. And let's just keep doing the amazing research that we're all doing, and basically find ways to collaborate, to share our knowledge and our experience and our, our research with each other, because I think we collectively, we have so much that we could do together, and we have so much that how we can strengthen each other through the collaboration. So that's really why I wanted to bring everybody here today. And we'll stay tuned for the next event.
Yeah.
Sure.
And,
Thank you for
yeah.
holding this.
Yeah.
Thank you so much. Thank you.
Yeah, thank you for coming. Thank you for coming. And if you haven't had a chance to take some food, please do, especially students.